For hundreds of millions of years after the Big Bang, it remained a murky, silent void, filled with swirling clouds of gas and dust. There were no stars, no galaxies, just darkness. Then, something extraordinary happened. Light burst forth, and the universe began its transformation. Stars ignited, galaxies formed, and the cosmos as we know it was born. But what if I told you that our understanding of this incredible story, the very origin of the stars and galaxies, might be completely wrong? With its unprecedented capabilities, the James Webb Space Telescope has taken us on a journey into the universe's earliest moments. What it's finding is shocking. Webb has stumbled upon evidence that doesn't fit our current theories, suggesting that the universe's history might need to be rewritten. Prepare to be amazed as we explore how the James Webb Telescope is cracking the code of our cosmos, revealing secrets that have puzzled scientists for centuries. Over the past century, astronomers have crafted a detailed account of the universe's evolution. This grand story, known as the Standard Model of Cosmology, has served as the foundation for our understanding of cosmic history. It's a model that explains a wide array of observations, from the redshift of galaxies, how light stretches as it travels across the expanding universe, to the cosmic microwave background, the faint afterglow left over from the Big Bang. In this narrative, the universe began in a nearly uniform state, with slight imperfections that gradually grew over billions of years. Imagine a calm pond, with tiny ripples slowly expanding and evolving into larger waves. In the universe's early days, these ripples were the seeds of stars and galaxies. According to the theory, as we look deeper into space and further back in time, we should see simpler, less evolved galaxies. They would be smaller, bluer, and sparsely populated compared to the grand spiral and elliptical galaxies we see today. But here's the twist. The James Webb Space Telescope is showing us a universe that doesn't fit this picture. It's as if we're looking into the past and finding ancient cities where only tiny villages were expected. The telescope has uncovered massive, fully formed galaxies appearing far earlier in the universe's timeline than our models predict. How could this be? To understand why Webb is making these groundbreaking discoveries, let's dive into what makes this telescope unique. James Webb was designed to see the universe in the infrared spectrum, which is crucial for studying the early universe. Here's why. As the universe expands, light from distant stars and galaxies stretches into longer wavelengths, a process called redshifting. Light that began as visible or ultraviolet is now stretched into infrared by the time it reaches us, billions of years later. Think of it like this. If you've ever heard an ambulance siren change pitch as it speeds past, you've experienced the Doppler effect. Something similar happens with light. As distant galaxies race away from us, their light shifts into the red end of the spectrum, turning what was once bright blue starlight into faint infrared. Webb's infrared capabilities allow it to peer through this stretched light, giving us a window into the universe's early years, times that were previously hidden from view. So, what exactly is Webb seeing that's causing such a stir? Scientists had expected to find small, chaotic galaxies in the universe's early days, akin to toddlers just beginning to walk. Instead, they're finding galaxies that look far more mature, akin to fully grown adults. Some of these galaxies resemble our own Milky Way, appearing as disk-like structures with well-defined features, even though they existed when the universe was just a fraction of its current age. It's as if you traveled back in time expecting to see wooden huts and primitive tools, but instead found skyscrapers and bustling cities. These mature galaxies shouldn't exist yet. Our models of cosmic evolution say they need far more time to form. This raises a profound question. Were the conditions in the early universe far more conducive to galaxy formation than we thought? Or is there something fundamental about the laws of physics that we don't yet understand? Adding to the mystery, the telescope has spotted small, solitary dwarf galaxies that defy expectations. Normally, we'd expect these galaxies to be interacting with larger companions or actively forming new stars. But instead, they sit quietly, their stars appearing ancient and their activity minimal. It's as if they exist in a cosmic bubble, untouched by the usual processes that shape galactic evolution. Webb's surprises don't stop at galaxies. It's also reigniting a long-standing debate about the universe's rate of expansion. Since the 1920s, when Edwin Hubble first observed that galaxies are moving away from us, astronomers have been trying to measure this rate of expansion, known as the Hubble constant. It's like trying to clock the speed of a cosmic race car. But here's the catch. Two different methods give two different results, creating a tension that scientists call the Hubble crisis. One method involves measuring the brightness of stars, called Cepheid variables, to gauge distance. Another looks at the cosmic microwave background, the afterglow of the Big Bang. These two methods should, in theory, agree on how fast the universe is expanding. Yet they don't. Measurements of the early universe suggest a slower rate of expansion than what we observe in the more recent universe. Now, with its unprecedented precision, Webb has cross-checked the Cepheid measurements and found that they were accurate, ruling out measurement errors. This only deepens the mystery. Why do these two methods disagree? Could there be new, unknown physics at work? Perhaps dark energy, the mysterious force accelerating the universe's expansion, is behaving in ways we've never imagined. As if challenging our understanding of galaxy formation and cosmic expansion weren't enough, Webb's discoveries also hint at mysteries involving dark matter and dark energy. Picture the universe as a vast stage, with galaxies, stars, and planets as the actors. But something is missing: the stage itself. Dark matter and dark energy are like the unseen scaffolding holding the cosmic theater together, shaping the universe's structure and evolution. Webb's data raises new questions about these elusive components. Could dark matter have influenced the rapid formation of these early galaxies? Are we missing a hidden force or particle that could explain what we're seeing? Physicists at CERN are hot on the trail, searching for dark photons, exotic particles that might be linked to dark matter. The Large Hadron Collider, LHC, is ramping up its capabilities, preparing to sift through more collisions than ever before, in hopes of catching a glimpse of these elusive particles. The revelations from the James Webb Space Telescope have opened the door to a new era of cosmic exploration. Other telescopes, like the European Space Agency's Euclid and NASA's Nancy Grace Roman Telescope, are joining the quest to map the universe's large-scale structure. Euclid aims to create a cosmic Google Maps of the universe, pinpointing the distribution of galaxies and dark matter. Its findings may help us understand how dark energy has influenced the universe's expansion. Meanwhile, astronomers are studying the light from these early galaxies in greater detail, searching for clues about their chemical composition. Did stars in the early universe form and die more rapidly, enriching their surroundings with heavy elements? Or did some exotic process create the galaxies that now defy our expectations? We stand on the brink of a new understanding. The James Webb Space Telescope has revealed a universe that doesn't quite match our models. It's like finding an ancient manuscript written in a language we've never seen before. The story it tells is familiar yet strange, filled with unexpected characters and plot twists that make us question what we thought we knew. Will we need to rewrite the cosmic textbooks? The answer is likely yes. Webb's discoveries suggest that the universe's early years were far more dynamic and complex than our theories accounted for. Whether it's the nature of dark matter, the formation of early galaxies, or the rate of cosmic expansion, something profound is waiting to be uncovered. So, as the James Webb Space Telescope continues its mission, one thing is certain: the universe is full of secrets, and we are only just beginning to unravel them. The story of the cosmos is far from finished, and with every new discovery, we are reminded that the universe is stranger, more wondrous, and more mysterious than we ever imagined. The universe is rewriting its own story, and James Webb is the cosmic pin bringing it to life. As new data streams in, scientists will continue to debate, hypothesize, and explore. The journey to understanding our universe is far from over, and the next chapter promises to be one of the most exciting yet.